Welcome to this NPTEL Phase 2 course on groundwater hydrology, which is being developed by me, Dr. V.R. Desai, and my colleague Dr. Anirban Dhar, both from the Department of Civil Engineering, IIT Kharagpur. First, let us start with this lecture number 1 in module number 1 on introduction. So, here we will start with the basic the meaning of the word groundwater and how it has evolved, which I would like to abbreviate as GW. So, this is the groundwater is the water available below the ground surface in soil or rock pores, also known as subsurface water, for the simple reason that it is available below the ground. And we all know that for to sustain life, water is the second most important requirement, next only to air, and it comes even before the food. So, water is used for various purposes, right from the drinking and cooking as well as other purposes, and the water required for this drinking and cooking is known as fresh water. Fresh water is the purest form of water used for drinking, cooking. The human dependence on water, on fresh water, water in general and fresh water in particular, it starts with the rainwater or else surface water else or else groundwater or else desalinated water or else other fresh water. So, here I would like to mention that the rainwater, as and when it is available, okay, and we know that the duration of rainfall is very limited, as well as many times the spatial extent of rainfall is also quite limited. So, if the rainwater is stored, can be stored in the appropriate containers before it gets polluted or contaminated with other impurities in the atmosphere or on the ground surface, okay, that will serve as the best purpose, because it has undergone the natural process of purification through this evaporation and subsequent condensation. So, and because of the spatial and temporal limitation of rainwater, so our the human dependence, if rainwater is not available, then we have to we have to sustain our life, not only for this human beings, so also for our flora and fauna, the plants and animals. So, they also need to sustain their life. So, therefore, the dependence moves on to surface water. So, here the this water may be available in any surface water body, maybe a river or a reservoir, or a small size reservoir like such as a tank or a pond, or even a natural reservoir like a lake. Okay, so, all these are one, and it also, the surface water may also be available in the form of say this mountain ice caps. Next, if that is also not available, then obviously the human intelligence tries to explore water by that is digging below the ground and then getting this one hoping for, and most of the time succeeding in getting groundwater, which is generally available in wells and other subsurface structures. If that is also not available, that means when rainwater is not available, surface water is not available, groundwater is not available, but the area is close to say a sea or any other source of large source of marine water. So, then we may go for say desalinated water. So, this desalination is essentially the artificial process of evaporation and then creating artificially fresh water. And if that is also not available, we may go for other sources of water such as fog water, or even mist, or any other any other form of fresh water. Okay, so therefore, and as you can see, so this groundwater here, it lies it is next only to rainwater and surface water. So therefore, it provides the necessary, that is water security spatially and temporally, and because it provides this water security, so it is very important to sustain life. And many times it has been proved that so this groundwater extraction has been proved to be easy and feasible technically and economically. So, this groundwater provides the necessary water security for fresh water in particular, spatially and temporally. Therefore, the extraction of groundwater, or rather the harnessing of groundwater, is very important. Now, let us go to the next item of this lecture, that is the groundwater utilization and historical background. So, coming to this groundwater utilization, I have already mentioned in the introduction that how important groundwater is to provide spatio-temporal security, water security. And this one in this groundwater utilization. So, this groundwater utilization is it is done in the developed as well as developing world. In the developed world as well as in the developed nations as well as developing nations. So, there has been significant amount of utilization of groundwater, because for the simple reason that it is providing additional water security. So, now let me give an example of say this an example from the developed world and also an example from the developing world. So, this is for example, in USA, in 1975 in USA, there were at least not less than 10 states wherein groundwater use divided by total water use was greater than 50%. So, because I am using the word not at least because I got this one the data only for say 45 out of 50 states, that is why I am using this word. And added to this, there were additionally there were not less than say 9 more states, 9 states wherein this is groundwater use divided by total water use. It was between 40 and 50%. So, you can say nearly say at least say 20% of the no 40% of the states in the US, okay, so depended significantly on groundwater for their for carrying out their activities, various activities. Now, and now let me provide an example from India, the recent one. Say in India, during 2004, so the groundwater development that is a development stage, okay, that is the groundwater extracted divided by groundwater available. So, this was more than 100% in 3 states of Punjab, Haryana and Rajasthan. Of course, this is not a healthy sign, but still you can realize the importance of groundwater. And we know that Punjab and Haryana are known as the agricultural powerhouses in India. So, you can imagine the importance of groundwater. And likewise, so in the National Capital Territory of Delhi also had a groundwater stage of groundwater development of more than 100%. And during the same year, so there were 5 more states, that is Gujarat, Karnataka, Tamil Nadu, Uttar Pradesh and Uttarakhand, wherein the groundwater, the stage of groundwater development was between 50 and 100%. And so this was also the case of Lakshadweep, the Union Territory of Lakshadweep. And of course, I forgot to add here. So that is 3 states of Punjab and 2 union territories, that is UTs of Pondicherry, Diu and Daman, DD. Okay, so this is PY for Pondicherry and DD for Diu and Daman. Likewise, so this is between 50 and 100%. The Union Territory of Lakshadweep had as one. So, like as you can say, so let me present this in a tabular form. So, that is India 2004, that is a stage of groundwater development. So, let me present this in a scale here. So, this is 0 and here say 40%. So, this is all in percentage, and say this is 50% and then this is say 100%. So, here above 100% we had this is we had the states of Punjab, Haryana, Rajasthan and the National Capital Territory of Delhi. And between this 50 and 100%, we had Gujarat, Karnataka, Tamil Nadu, Uttar Pradesh, Uttarakhand and Lakshadweep. Okay, so these 5 states and 1 union territory. Between 40 and 50%, so there were few more states of Andhra Pradesh, Kerala, then there was Madhya Pradesh, Maharashtra, West Bengal. So, you can imagine the importance of groundwater utilization. So, here you can see that is say this is 1, 2, 3, 4, 5 and then say 10. So, at least 13 states which covering almost more than 50% of the physical area, 50 to 60% of the physical area of India. So, they were dependent on groundwater for significantly. So, this explains the importance of the groundwater utilization in the developed world, for example, the USA as well as the developing world such as India. So, now let us come to the historical development of groundwater in the historical background, and we know that the one of the oldest river valley civilizations, the Indus Valley civilization. So, that time there have been records of groundwater wells, that is they were essentially open wells used for irrigation or even municipal purpose also. And also the Old Testament, it contains a number of references regarding groundwater, springs and wells. So, around the same period in India, So, during the Mauryan Empire, and we know that the Ashokan, the Mauryan Empire under Emperor Ashoka, it extended all the way from the present Afghanistan to, so in the eastern India, close to West Bengal and even Assam and all. So, there are records of groundwater wells supporting irrigation, and even so there were many wells were constructed so as to facilitate the travelers. So, during those days, so there were not many communication facilities, and so under these one, so there were many this one. Okay, so that means so this is historically one. Of course, I would like to show you here, that is the same thing, that is before moving back to this one, I would like to show you here the so which I mentioned here, the state wise groundwater resource availability, utilization and all. As you can see here, let me highlight the ones with more than 100%, and similarly Punjab and Rajasthan more than 100%, and even say this is Haryana more than 100%. And I am sorry, it is not very visible, that is because it is a too big a table. So, like that this one. Okay, let me also share with you the replenishable groundwater resources in India. As you can see here, in the states of Punjab, this is Haryana, Delhi, then almost in Rajasthan also. So, it is one. So, here there is a significant amount of the groundwater utilization. Added to that is the states of Gujarat, Maharashtra, Madhya Pradesh, Karnataka, Tamil Nadu, and say West Bengal, Uttar Pradesh. Of course, here it also this is an old map of India with so therefore, it does not show that the new states of Uttarakhand, which is carved out of Uttar Pradesh, and Chhattisgarh, which is carved out of Madhya Pradesh, and Jharkhand, which is carved out of this one. So, as you can see here, a significant area, of course, Andhra Pradesh also. So, in all these states, the stage of groundwater development is at least 40%. So, you can imagine the importance of groundwater. So, now let us come to that historical background. So, here during Indus Valley civilization, there are reports of groundwater use through open wells. So, this is at least 5000 years ago. Similarly, so in Old Testament, there are references to groundwater, springs, and wells. Around the same time in India, so there are mention references of to groundwater wells supporting irrigation during Mauryan Empire. So, that is 4th and 3rd century BC. So, like this we can say how important is groundwater, which was realized by human beings in and also now let me also bring it to you a very interesting technology of horizontal wells. So, we are under the impression that so this groundwater wells are essentially vertical wells. It is not exactly so. There are many examples of horizontal wells, and these horizontal wells are supposed to it has been proved that these horizontal wells have a even greater yield than the vertical groundwater wells. And in this regard, I would like to mention to you the about canards, which are the horizontal wells which were found in which were initially developed in say Iran. So, this is a typical canard, and as you can see here in this this is a horizontal well. So, this essentially is the canard, and the deepest well is known as the mother well, and so this is the water intake area. So, basically this is a hilly area or a mountainous area where there is a significant amount of rainfall, and this mother well has a depth of around 50 meters or less than that, and there have been examples of mother wells which are even as deep as say 100 meters, and one mother well has been reported to be around say 250 meters deep also. And then so here, so the unlike the mountain slope which may be very steep, so this the bed slope of this canard, which is essentially a horizontal well, horizontal and mild sloping well. So, this is the slope direction. So, this is a very mild slope, and it reaches the ground, and once it reaches ground, so for a significant portion there is a surface canal, and through this surface canal the water is conveyed to the farmlands or irrigated land, and in between the mother well and this surface canal, so there are a number of these shafts. Okay, and so this is the conduit of the canard, which forms the horizontal well, and so these number of shafts are the one which provide access to this drilling this canal. And so this canal, this canat, so this canat was the technology of drilling this canat, wherein this water from the aquifer was brought in through the mild sloping horizontal almost horizontal conduit of the canal in to the surface canal and then on to the farmland. Okay, so this was very much perfected by people in Iran almost say 3000 years back. And here, so the length of the canat I am sorry, was of the order of say 5 to 30 kilometers. Most of the canats are existing even now, and so it has been reported that there are at least 22,000 canats existing in Iran even now, and which will supply which are supplying at least 35% of the entire water requirement in Iran. Okay, so here I would like to mention here. So that is how important is the groundwater essentially. So this is a horizontal well technology which was very much perfected in Iran, and from there it moved on to this Morocco and this other North African this continental regions, and then it moved as far as Spain in Europe. So like this, so the the extraction of the historically this groundwater has been extracted not only through this the vertical wells, also through the horizontal wells. And now let me bring it to you. So this is you must have heard of the artesian well, and here, so in this artesian well, it is basically it was developed initially somewhere in France in a place called Artois, and in this case this is basically a pressurized well. So here we have the that is free water table is somewhere here, and then in this region where the ground surface is below the free water table, so there the water is under pressure. Okay, and here if we puncture this one, then the water will gush out of this artesian well, and so it will give out water in the form of a natural fountain. So this region wherein the ground level is below the water table, okay, so that is known as the region of artesian water, where there is a raised water table. And so if we puncture this artesian aquifer, so there will be a huge amount of, we can get a lot of water. So these artesian wells also were developed sometime in the middle of this one, and added to this is the, so in 1804, so there was an instance of the first deep tube well which was dug in and around Calcutta, and so it had a depth of 500 meters, and so this tube well was the you can say is the major this one it indicates a major milestone in this groundwater harnessing or development. Likewise, in 1936, so this Ganga Valley State Tubewell Irrigation Scheme. So here I would like to mention, so that is the, so there are at least 22,000 canats that is horizontal conduit wells in Iran even now, supplying at least 35% of the water requirement of Iran. So, you can imagine how important it is, and added to that is, say, that is the in 1804 the there was groundwater development through a 500-meter deep tube well or say bore well around Kolkata in India. So, there was a reported okay, and so in 1936 Ganga Valley State Tubewell Irrigation Scheme was launched in UP with 1500 deep tube wells. Of course, there have been parallelly there have been many developments in the Western world also, and so obviously it all shows how important is the groundwater development. And here let me also show you an example of a horizontal well, and as you can see here there is an aquifer with water table here, and that is there is a sloping side, and so this aquifer is bounded by an impervious barrier and then say some rock formations here, and so through this, so there is a this horizontal well, and of course, so the so depending upon the water table, so this we can groundwater can be harnessed to this horizontal well. So, now let us come to the that is the groundwater in hydrologic cycle. So, here I would like to, which is also known as the water cycle, and here, so this is a schematic diagram, and as you can see, so this is the ground surface, and so this is a surface water body such as a lake or a river, and so this is the groundwater table which represents the level of the saturated groundwater, which also joins the sea or ocean. And here, so there is evaporation from the ocean surface, from the land surface through evapotranspiration, as well as from the surface of surface water bodies such as a lake or river, as well as through these plants. And then so all this evaporated water, so it gets accumulated in the clouds which are formed here, and then so these clouds they move, and then so there will be a cloud condensation, and then there will be precipitation, which may be either in solid form through snowfall or hailstorm or whatever. And so this precipitated water, it will percolate through the ground surface, and eventually it will form so what are known as the aquifers, which are the water bearing strata. And of course, here there is a bedrock also, and then so there are also among the aquifers there are confined as well as unconfined aquifers, and then so there is so these confined aquifers which are at the deeper depths, so they get their water from this deep percolation. So here, so this is a deep percolation, and then so this is the shallow or the top or the water table aquifer is also known as the unconfined aquifer. Okay, and so now coming to this the hydrologic cycle, we know that so quantitatively, so we can represent the same thing, that is a hydrologic cycle. So here we can say this is a, so this is the clouds, and here, so this is the atmospheric segment of the hydrologic cycle, and then so here there is also, so there is this is evaporation and evapotranspiration, and then here, so this is precipitation. Okay, and then so there is so this is the surface runoff, and then so there will be infiltration, and then so here there will be, so this is the groundwater table, and so here this is the ground surface. So this is the surface water body, and then here you can say this is a sea or ocean. Okay, so essentially, so this is a cycle, and in this case, now let me explain you the various quantities involved here. And as you can see, so this sea or ocean, so this represents almost say 96% of water by volume. And of course, so here there are these, so these are the mountain ice caps. And of course, so here there is a also this is a, so this is the groundwater, okay, in this confined as well as unconfined aquifers. So here I would like to, so this I would like to, so this is the unconfined, that is water table, aquifer at the top, and here, so this is the, just schematically I am showing this one. So, this is the confined aquifer at the bottom, below that. So, this is the hard rock here. So, like this, and as I was mentioning, so this sea or ocean water represents say 96% of the water by volume. So, the remaining nearly 3 to 4% is the fresh water, and as I can show, let me show you here. And so, this is the brackish or saline or other water, which represents say almost say 97.5% of the total volume of water on earth, and only this 2.5% is fresh water. And of course, this 97.5% we cannot use it for our to maintain the metabolic activity of human beings, animals and plants. And this 2.5% of water, and is out of this, so nearly 70% is stored in the polar ice and glaciers, and then so this 30% is stored in groundwater, and of course very little, say 1/4 of a percent of fresh water is available in the surface water bodies. And here, and this so therefore, as soon as we can see, so this polar ice or glaciers, they are available only in the cold regions or high mountainous regions, whereas groundwater is available almost everywhere, the fresh groundwater. So, and here, so this fresh groundwater up to say 1 kilometer depth, so it is nearly half of that one, and then below 1 kilometer depth, so it is the remaining half, and then of course very small percent of that is soil moisture. So, here, so this as you can see, this hydrologic cycle, so there is a significant amount of this one. Let me go back to you again, this hydrologic cycle. So, although the entire water, the global water volume is of the order of say around 1400 million that is kilometer cube. So, out of that, so nearly 96, say 96 to 97% is the brackish or salt water or marine water. So, therefore, so this as you can see, this 97% of water is useless. So, it is only the remaining say 2 to 3% of water, 2.5% of water. So, out of this, so 1/3 of that is available in groundwater, and this groundwater is available in say almost all the regions rather than the mountain ice caps. So, the mountain ice caps are available only in the mountainous regions or the polar regions, whereas this groundwater is the fresh groundwater is practically available everywhere. So, therefore, how important it is to that is manage this groundwater, to maintain its this one supply and demand, and so that this water table, and as you can see here, so this water table, so it should be at the reasonable depth below the ground. It should not be too deep, it should not be too shallow. So, if it is too shallow, then it may create waterlogging or that is drainage and waterlogging problems, and if it is too deep, then this extracting of this groundwater will require lot of energy, lot of costs. Many times these days we have the high capacity pumps which are used to extract groundwater like multi-stage submersible pumps and so on. So they are used for extracting groundwater through these wells. Okay, and so therefore, to make it technically as well as economically sustainable, as well as ecologically sustainable, we need to maintain a balance between the groundwater availability, groundwater supply and demand. So so that we can maintain the depth of the water table, a healthy depth of the water table, which is neither too shallow nor too deep, and we can also maintain the balance between the groundwater supply and this groundwater demand. So thereby, so we can provide the water security in the form of fresh groundwater, which is practically available everywhere in the nearly 29% of the land surface on earth. On the other hand, so this at the same time, so this the recent this climate change and associated impacts, so they are also affecting this one. So that is they are affecting this one, and so these climate change impacts are causing the mountain caps to the polar ice as well as glaciers. Of course, here let me also write here, this is glaciers, the melting of glaciers and polar ice, and so therefore it is extremely important to see that. So the water which has melted because of the climate change and the global warming effect, so is stored in the form of groundwater, and so in the next lecture we will see the other aspects of so this. Thank you.